Okay, this next section is a bonus section, and there was probably a couple problems that kind of alluded to this in section 7.6. But what we're going to do here is we're going to really dig into coordinate proofs. So if you flip actually to the back side of this worksheet, you'll see a problem here that we'll try to do together, and you'll get a sense of what my expectations are for you for these coordinate proofs. So I'm going to go ahead and label these points. So I'm going to give this an A, a B, a C, and a D. And I'm going to go ahead and graph these points. So here's where D is. A is right here. B is over here. And C is right there. Okay, and so you have a figure here, and you can kind of take a guess as to what it is. You might even be able to eyeball it and go, it's got to be well, you know can't be a square. But you need to prove it, okay? And the way you do this is you do this algebraically. And so what you're going to do here is the best thing to do is probably to start out with trying to see if it's a parallelogram first, okay? Just like we were doing with the squares problems, we're going to check to see if it's a parallelogram. So I'm going to find the slope of all the sides to see if I have opposite sides congruent or parallel. So the slope of AB, the slope of BC, the slope of AD, and the slope of CB like this. And I'm going to show the work 1/5, -1/5, -5, and -5. And then from that, I can conclude that because of that, I have congruent slopes, which means that you have two pairs of opposite sides that are parallel, which means it's a parallelogram. Two pairs, opposite sides, parallel. And then from there, just because it's a parallelogram, I can't stop there. I need to check to see some things here. I need to see if it's a rectangle. And hopefully you can see just from this, slopes are not opposite reciprocals of each other. So what we're doing here is we're basically checking to see if this is a right angle. Okay, is that a right angle? Question mark. So it's not a rectangle. And I'm going to check to see if I have a rhombus. And the best way to do that, maybe, I can do distance formula to check to see if these are congruent to each other. That's one way to see. Check the distance here and check the distance there and see if they're the same. Another route that I can take is I can check these slopes and see if I have a right angle here, see if they're opposite reciprocal slopes. Okay, so I'm going to do that one just because. I'm going to check the diagonals. So the slope of AC ends up being equal to 4/4, which is just 1. And the slope of DB, if I do the slope there, I'm going to end up with -1. So these are going to be opposite reciprocal slopes. And therefore, those two diagonals are perpendicular to each other. So now I have a parallelogram. So I have a parallelogram, and I have opposite I have diagonals perpendicular. So that means that I have a rhombus. Okay, and I already know it's not a rectangle, which means that it is not a square yet either. So, not a square. Okay, so really all I needed there was to say it's a rhombus and show that it's not a rectangle, so therefore it's not a square, and therefore it's just a rhombus. And that's what you need to lay out as far as doing a coordinate proof. You need to show the work, show the algebra, and then just give little phrases to explain your reasoning as far as why it's the certain shapes that it is, and also make sure you're checking to see if it's not any additional shapes. Okay, and that's all I have. I'm going to let you go ahead and try some problems on some coordinate proofs. All right, take care.